Hey Brian, this is just a continuation. I'll work out a problem here for you on the Maclaurin series. Again, I've written the formula for the Maclaurin series here. And just to recap what we're looking for in this, the C equals 0. So we are only looking for the sum of all of the nth derivatives of 0 times x to the nth power divided by n factorial. Now, what does that mean specifically? That means that we're looking for f of 0, that's when n equals 0. When n equals 1, we're looking for the first derivative of 0 times x. N equals 2 is the second derivative of 0, x squared over 2 factorial. N equals 3, we have the third derivative of 0, x cubed over 3 factorial, and one more we'll do. N to the fourth is n to the fourth derivative. Remember, we're going to write that in parentheses like that. Of 0, x to the fourth, divided by 4 factorial. Now, let's say that I have a polynomial, and I'll kind of draw it like this. And let's say that it somewhat looks a little bit like that. We'll call this is my f of x. Now, what I want to do is I want to find out, is there some power series that I can rewrite that is going to mimic this series? Now, again, when c equals 0, what I'm wanting to know is about right there. What happens about right there? This is specifically when f equals 0. Now, what I can do is if I take just what it is here, f of 0, if I say, well, okay, well, it's f of 0 is that point. That doesn't tell me anything. I can't really do a whole lot with figuring out what the graph is. Now, if I were to take the first derivative of this, remember that f of 0, that's a constant. I don't have any x's to go along with it, so if I take the first derivative of just this and make that the first derivative, that gives me a constant, and that constant specifically is 0. So that means that what I could do is I can then draw a line so that it looks like that. Now that line doesn't really look a lot like the curve that we had originally, so maybe we need to go a little bit further. Let's take it a step further. If I were to then say, well, what if in this instance I had p of x equals p of 0. We took the derivative of that. That didn't really work out for me. So now let's try it again. So this is our first attempt. Let's look at our second attempt. So if we do that, then let's say, okay, well, if p of x equals, what if it equals f of 0 plus f prime of 0 x? Okay. Well, if we do that, then let's take the first derivative of this. P prime is this. We take the derivative of everything on this side. Remember that f of 0, this is a constant because there is no variable. This is just 0, so I get 0 plus. And then what I'm left with here is this is a power of 1. Remember that f prime of 0 is a constant as well. This is a constant times a variable. When we take the derivative of this, we're just simply left with this, which means that p of x, or p of 0 in our case, happens to equal f of 0. Okay, well, so far we're okay. But let's try it one more time. Let's take it a step further. And then let's say that p of x equals, we're going to keep the same items that we had up here from before, f of 0 plus f prime of 0 times x plus f second derivative of 0. This time we're going to do x squared. But now watch this. Remember up here we said that it has to be divided by 2 factorial. 2 factorial is just 2. Okay, so we do that. And then if I were to take the first derivative of this is, again, this is a constant, so it goes away. The derivative of a constant is just 0 plus the derivative of this guy right here, which is just simply f prime of 0. I'm sorry, this just goes away. Yeah, that's right. It's f prime of 0. And then what about this guy back here? Remember, this is a constant. F double prime of 0 is a constant. We have this power up here, so remember that power comes out front, so we get 2 times F double prime of 0, lower the exponent, just becomes x, divided by, again, 2 factorial is just simply 2. This then just factors out. So then what I'm left with is P of x equals F prime of 0 plus F double prime of 0 times x. Well, look what happens here. This gets me back to this piece. So what this tells me is that I'm actually on the right track. So if we were to take just this piece here where we had the straight horizontal line like this, if we then were to come through and we were to graph our second guess, we're probably looking at something about like this, where we found a tangent line. And remember, the tangent line, that's the very definition of the first derivative. You're trying to find the slope of the tangent line. As we continue to add these on here, maybe the next time, maybe I'll get something that looks like this. And then maybe the next time I'll get something that looks a little bit like this. Eventually, as we continue adding on it, and the n gets higher and higher and higher, to eventually where we end up with this guy right here, eventually we will get something that mimics very closely with our original function. Okay, so now I want to do a specific example on this, and the specific example that I want to use is the f of x equals cosine of x. So we'll say the f of x, this is again the Maclaurin, f of x equals the cosine of x. Well, let's just go ahead, since we know that we need to do multiple derivatives of this. So we'll write down f of x is this. Then that means that the f prime of this, remember that the derivative of cosine of x is negative sine of x. Let's take the second derivative of x. The derivative of sine of x is cosine of x, but I have this negative out in front, so that then leaves me with negative cosine of x. Let's do the third derivative equals cosine of x. The derivative of it is negative sine of x, but I have a negative negative, so that then becomes positive sine of x. And let's just do one more for good measure. Again, we're going to write this as the fourth derivative like that of x. The derivative of the derivative of sine is cosine of x. So this is what we have here so far. Now let's treat this, remember that Maclaurin, this is when c equals 0. So let's treat this as f of 0. So we're going to do the same thing. We're just going to say f of 0, so the cosine of 0, and the cosine of 0 is 1. Your derivative is negative sine of 0. Sine of 0 is 0. Negative 0 is still 0. F double prime of x equals negative cosine of 0. Cosine of 0 is positive 1, but we have a negative out front, so that becomes negative 1. Third derivative, sine of 0. Again, the sine of 0 is just simply 0. And then one more, the fourth derivative of x. This equals the cosine of 0, which we've already said before is 1. Notice we have a 1, 0, negative 1, 0, 1, 0, negative 1, 0. And this pattern will continue on and on and on and on like that. So now let's use the Maclaurin series that we had originally. So we'll call this P of x. Remember we said P of x is going to equal f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial plus f triple prime of 0 x to the third over 3 factorial, and then one more, the fourth derivative of f of 0 x to the fourth over 4 factorial. And then, of course, that continues on and on and on. So now let's look at what we have here and see how that works out. So we've already set up here f of 0 is 1, so we just start off with 1, plus f prime of 0. What did we say f prime of 0 was? F prime of 0 is 0. 0 times 1 is just 0, so that's that. Plus f double prime of 0 we said is negative 1, so that's negative 1 x squared over 2 factorial is just simply 2, plus f triple prime of 0, which we said is 0, so we then have 0 times x to the third, which is just 0. 0 divided by 3 factorial is just simply 0. And then the last one, the fourth derivative with respect to 0 is 1. So we then have 1 times x to the fourth, which is just x to the fourth, over 4 factorial. And that continues on and on and on. Well, obviously this goes away because it doesn't count. This goes away because it doesn't count. So then we can simply rewrite it and say 1. This is plus a negative, so this becomes minus x squared over 2. This again goes away, plus x to the fourth over 4 factorial is 4 times 3 times 2 times 1, which is 24. And then plus, and this goes on. And I can actually continue to write this out if I wanted. I could then say, remember they alternate terms, positive, negative, positive, negative. This becomes negative. What happens here? 2, 4, 6 over 6 factorial. Again, plus, this one's going to go 8 over 8 factorial minus x to the 10 over 10 factorial, and it continues going on and on and on like that forever. Now, what I want you to do is take this piece right here, and I want you to graph that using something like Desmos. Graph this and see what you get, and see how closely you can get to where it mimics the actual version of cosine. So if you were to go through and graph this out, by the time you get to x equals 10, you may not get enough that's going to show you what the true version of cosine is. But if you continue to go on and on and on forever, you would eventually get it to where it would then resemble your cosine. And again, cosine is going to look something like this. Forgive me. But eventually it will look something like this. And if you were to go through and try to graph this, you would also then end up with something that looks very similar to this. Now, what does that help us? Let's say that I wanted to find the sum of n equals 0 up to 3 of cosine of x. You could simply plug it in here. Obviously, you would know that you need to stop about right here, and it would just be this piece right here because this gets us a little bit bigger. So that would mean that the sum of n equals 0 up to 3 of the cosine of x would equal simply 1 minus x squared divided by 2. And in the next one, I'll show you how to do one for the Taylor series.